this next graph called the stem and leaf plot is my favorite graph. I learned about this graph when I was teaching and I had never seen it before. So let me tell you everything I know about this graph because it's amazing. The first thing we see is quantitative data or numerical data. So we're introduced to a new key term, quantitative and numerical. These two terms mean the same thing. They're interchangeable. And this is information that consists of numbers. Okay, so remember last time in this example up on top, we were talking about categorical data. So these are the two things you've learned, categorical. And categorical is labels such as names and stuff like that, okay? But this one, we're going into numbers, and these are numbers that are measured or counted. Okay, so in examples of categorical data, so any number, the first one I have like this huge set for you, 17, 19, 20, 24, 24. You see the repetition of numbers, so it's just a bunch of numbers. So quantitative means quantity, or qualitative means like a title. Okay, so moving on, the first graph we see is a stem and leaf plot, or stem plots, known for short, are used to organize quantitative information. So one of the key things here is organize. I like this word organize because when you see this data, so this right here is called raw data. That means that, maybe it hasn't been organized in any way. It's just data that you went out there and collected. I want you to picture that scientific person I described earlier with the white coat, the goggles, the clipboard, right? It's just messy data. And we're going to organize it into a stem and leaf. So in a stem and leaf plot, each number is separated into a stem and a leaf. Okay, so here is the stem part. So all of this over here is a stem. And then this part over here is the leaf. And it's probably exactly what you're picturing, kind of like a flower, where I have the flower. I'm an awful artist, guys. And then I have a leaf coming out of it, right? So here's this leaf, right? And the middle part is the one holding everything together. Okay, so this is the stem and that's the leaf. The stem represents the entry's leftmost digit, and the leaf the entry's rightmost digit. The stem plot contains the original data. Oh, that is a lot to unpack. All right, I'm going to give you a number, and I'm going to tell you that this is the left and this is the right. You're thinking, duh, well, of course it is. But that's what that means, right? Where it says right here, the stem represents the entry's leftmost digit and the leaf's entry's rightmost digit. So in here, if you come and look at, I know I've highlighted a bunch of information, but if you come and look at this key, it's very important because it tells you that if I pick a number from the left, okay, this is the left, it's going to be in the tens place. And this one, this one is the right, and this is going to be in the ones place. And together, they make 30. This is super important. I know you're reading it and it looks so simple, but sometimes when students are on their own, they have a little bit of a hard time. So I want to say, don't worry if you have a hard time. Come back and look at these notes. Do whatever it takes so that you can put all of this information together. The last thing that it says is that this stem plot contains the original data. I think this is kind of like a future piece of information, but I want to unpack it now and I want to tell you that this is important because in other graphs, once you create a graph, you lose the original data. You just have this organized fashion of looking at it now, but the original things that you wrote down aren't there anymore. And in this one, it is there. So this is a very special graph. It's neat. Remember the most important things that I need you to look at. I need you to look at title. So what's the title of this graph? It's number of texts sent. So we're looking at somebody who sent text. Axes, in this case, it does not have a x-axis and y-axis. And then key is our last thing. Does this have a key? Yes. Did I learn how to read it? Yes, let's go over it again just one last time in case you didn't catch it. It says, the key says, if I grab a number from the left and a number from the right and put them together, it makes a 30. Okay, so that means that the 3 is in the tens place and the 0 is in the ones place. It's not always going to be like this. Sometimes it could be in the hundreds place, sometimes it could be money. So you got to be aware of what example they're giving you. All right, so then my last most important thing that I need to ask you to do is I need you to grab a number, an example, and give yourself a sentence. I'm going to do this, 17. Maybe you're thinking, 17, I got it. But you got to put this in a sentence. So one person, okay, and how do I know it's one person? Because the 17 is there one time. So 17 was, one person sent 17 texts. One person sent 17 texts. And you know, I'm kind of even making up the one person because I don't know if this is talking about people or if this is asking me like at different times of the day, how many texts do you send, right? But what I mean by the one, this is really important, is because you only see it once. And later you're going to see that you can see a number twice. Let me show you here. This is a 43 and this is also a 43. Okay, we're going to see that shortly when we're learning how to answer all these questions. Great, I kind of feel ready to keep going. I'm not going to talk about the frequency histogram yet. Let's go into the stem and leaf plot. So the stem and leaf plot shows the overall grades of a developmental math course at EPCC. Okay, so overall grades of somebody taking developmental math. So first thing I do, I read the title, overall course grade. Okay, there's no axes, and then the key. The key means that if I put a number on the left, which is a 2, and a number on the right, which is a 5, then it brings together a 25. So I go in and grab an example. And in this case, well, I won't pick 25, right? Because you already know that one. Okay, let's pick 1 and 0. So my sentence, one person earned a 10 in math class. Okay, I feel like I understand. I feel like I'm ready to tackle the sentences. Don't forget to answer incomplete sentences. Find the key. Ooh, okay, I know where the key's at. The stems represent which place value. So let's label this. This is the stem. This is the leaf. It's always in this order. Okay, so if together they make a 25, so then the stem is in the tens place. In the key, each leaf represents which place value? The leaf is in the ones place. What was the total number of students in the course? Ooh, all right, this is a tough question. Each leaf is a grade. And each grade, hopefully you know this, represents a student because I'm not going to give one student two different grades, right? So each leaf is a grade. Each grade is for one student. So that's really important, right? So those are things that come in with your knowledge. This is not something that's provided to you in the problem. Like I said, statistics is about reading and understanding. So we're going to count how many grades are given here. Now, I don't have to go in and put the stem and the leaf together. What I have to do is count the leaves, right? So this is going to be, for example, this is a 10. This one is an 11. This is a 25. This is a 30. This is a 34, right? With this 3 and this 4. Now, I'm going to get real tired of writing all these numbers. So eventually, I'm going to write them down anyway. But eventually, I'll tell you what I usually do. So I'm going to write 70, 70, 70. How many 70s do you see? I see 3. So 71, 73, 75, 76, 77, 77, 78, 78, and 79. And then 80, 81, 81, 82, 86, 90, and 98. Ooh, I hope I didn't miss anything. But that took me a long time. So let me tell you what I would do instead. If I already understand the graph, I would come in here and count the leaves. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. 26 grades. And if I go in here, I'm not going to count them, but if I go in here, these should also be 26 things, right? So, whew, there's different ways you can do things, and it's always important to know that you have options. There are a total of 26 students in the course. How many students scored a 50? Okay, so scored exactly a 50. I know it doesn't say exactly a 50, but it's asking me for a 50. So I'm going to come in here and I'm going to look for 50s. So it's really neat because over here, I had written a list for you. But if you hadn't written that list for yourself, then you come over here and you look in the graph. So exactly one student scored a 50. How many students scored a 60? All right, so I come in here. First of all, let's look through my list. If you notice, there's no 60. And if you notice here, there's no number. Actually, I should say no leaf. That means nobody scored a 60 exactly. How many students scored in the 70s? Ooh, this is such a pretty question. This one is different in the 70s compared to a 50. Look at that, the difference in questions. 70s, what are 70s? 70s are 70, 71, 72, all the way to what? 79. So how many students scored in the 70s? So you're going to look at all that STEM with a 7. So here, I'm looking at all of this, right? So how many students was this? This was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 students scored in the 70s. Ah, beautiful questions, y'all. Okay, identify interesting features in the plot. Look for big ideas rather than individual entries. So let me remind you what an individual entry is. If I go in here and I say, a student scored a 90. I'm like, oh, okay, great. That's an individual thing. That's like a, just such a small idea. So what I want to say with a big idea is something like most students, very few students, something that gives you a general idea of this course, especially of the grades. So I would say most students in this course scored a what? 70, I think, right? I can see because it's one of the biggest, I might even be tempted to call it a bar, right? If I'm looking at it this way. Most students scored in the 70s, and I think that's a really important fact. Whenever you're wanting to analyze data, whenever you're the one that's kind of being explained something, I want to know what's happening to most people. So those are big ideas. All right, I hope you can come up with your own big ideas. Like always, I do one and you try one. So you try on this one.